We know how to represent integers in binary, but how do we represent fractions? Well, we understand the sequence of units which go like this. So 2 to the 0, which is 1, 2 to the 1, 2 to the 2, 2 to the 3, and then 2 to the 4, and so on. So 2 to the 1 is 2, 2 to the power 2, that's 2 squared, which is 4, 2 to the power 3, which is 8, and 16, and so on. But this also goes in the other direction. So what we can have is 2 to the minus 1, 2 to the minus 2, 2 to the minus 3, and again we can continue off in that direction as well. So 2 to the minus 1, which is a half, 2 to the minus 2, which is a quarter, 2 to the minus 3, which is an eighth, and we can keep going on like that. So those are quite easy to remember. So again, it just halves each time. So we have a half and a quarter, and a half of a quarter is an eighth. And the next one would be a 16th, and after that would be 1 over 32. So by way of example, we're going to represent the number 6.75 in binary. So we work it out in a very similar way when we're converting integers between denary and binary. So first of all, let's work on the 6. So the 6 is made up of the 4 and the 2. So the 8 is going to, corresponding value for that is going to be 0. The 4 and the 2 gives us the 6. And 0.75 is 3 quarters. So that's made up of a half and a quarter. And then the other values are going to be zeros. Now, this is kind of the bit that kind of doesn't make a tremendous amount of sense, but we kind of have to imply a point in there somewhere. So we're going to do 0, 1, 1, 0. So this point now is implied. It's not real, but it's just implied. And then we've got 1, 1, and then we can have as many zeros after that as we want to. So we'll just put a couple down. And then that is 6.75 represented in fixed point binary. Let's just try this again with another example. So we're going to try and convert 9.125 into the binary fixed point representation. So first of all, let's try and work out the 9. So it's the 8 plus the 1, so that gives us the 9. And 1.25 is an eighth, so that's too big, so that's an eighth, and that's gives us 0, 0. So now 9.125 in fixed point binary representation with our implied point is that. So we don't need to put on the trailing zeros, so that gives us the 9.125. There are some fractions that we just simply can't represent using binary. So let's just have an example with this one here. So 0.1, how do we represent that using binary? Well, to start with, all our whole numbers here, they're all going to be zeros for us. A half, that's too big, so that's 0.5. A quarter, well, that's 0.25, so that's too big. An eighth is 0.125, again, that's too big. A 16th is actually, and I'll just write this down, 0.0625. And so that's going to be okay for us, 1. And 1 over 32 is 0.03125. So that's also going to be 1. So if we add those two together, what we actually get is 0.09375. So although pretty close to 0.1, it's not actually 0.1. If we wanted to get closer to it, we could go further along. So we could go 1 over 64, 1 over 128, and so on. So we could keep going. But no matter how far we went, we're never going to be able to represent 0.1 exactly. So we can get closer and closer to it if we include more bits, but we're never actually going to get there. So in this example here then, 0.1, the closest we can do is going to be 0.00011, and that's the closest and the best we can do in this circumstance.